Okay, first thing I want you to do today is actually complete the warm-up at the top where those first three problems are. So going back to factoring, it's been a few weeks since we factored. Go through and factor each of these trinomials and then continue the video. Okay, so here I have those three trinomials factored. And what you should notice is that they all were perfect square trinomials. Okay, all of these are what we call perfect square trinomials, where we get that same parenthesis twice and we can write it as a single parenthesis squared. And then it says, what's the relationship between B and C in each of the problems above? So if we look at how this factors, it always gives us that same term twice. And if we look at B and think about where that number comes from, 3 is half of 6, right? 12 is half of 24. 9 is half of 18. And so I always have half of B here. And to get to C, the reason that that works is because 3 times 3 is 9. 12 times 12 is 44. 9 times 9 is 81. So B and C have this relationship where if I take half of B and I square it, it will always equal C in those perfect square trinomials, okay? And so we use the fact that this relationship exists to do what's called completing the square. Now, completing the square really means we're creating a perfect square trinomial. Okay, so perfect square trinomial, like the one up above, where we know it factors into a single parenthesis squared, okay? And so what we're going to be doing is looking at a problem and deciding what value would go here, what would be the C value to create a perfect square trinomial, or to complete the square. That's why it's called completing the square. And we just talked about that we get from doing B over 2 squared, okay, that we use that relationship that it's always half of B squared gives me my C value. So let's look at the trinomials below. So it says find the value of C that makes each trinomial a perfect square trinomial. So it just says x squared minus 4x plus C. Now if I take my B value, which is -4, and I divide it by 2 and square it, what would that give me to complete that square, to complete that perfect square trinomial? So -4 over 2 gives me -2, squared gives me 4. So x squared minus 4x plus 4 would be the value, the C value that I would use there to complete the square, which would then factor into x minus 2, or x minus 2 squared, okay? So the C value that I would want there would be +4. On our next one, again, we look at our B values. So 6 over 2 squared, or 3 squared, gives me 9. So to complete the square, I'd have x squared plus 6x, and I'd add a 9 on, and that would create the perfect square trinomial. So here's the C value that I want. And then we know that these perfect square trinomials factors into the same parenthesis twice. This would be x plus 3 squared if I factored it. Now, it's not always going to be as pretty as 4 and 9 for the results when we try to create a perfect square trinomial. So if we look at our next example, where B is -3. Now, 3 can't be divided in half evenly. So we're going to get this -3 over 2 squared, which gives me 9/4 for my value for C to complete the square. So I'd have x squared minus 3x plus 9/4. Now notice it's always going to be plus C because, let me go back up to the top, because if it's a positive times a positive or a negative times a negative, it's always going to give me a positive value at the end. So in order for it to be a perfect square trinomial, it'll always be plus c to create that perfect square trinomial. Okay. Now, with this one and this one, it was easy to factor. With this one, it might be hard to think about, well, what would this factor into since I have a fraction here? So another thing that I want to point out is that this value, let me grab a different color just so it's not all pink here. This value here, this -2. So let me go back up actually and write out the steps. So I had -4/2 squared, which was -2 squared. That's how I got to my +4. This value is just what's inside the parenthesis, is the b/2. And same here, when I did b/2, it gave me 3. Then I squared it to get my value. So this value again, here, right there, is b/2. And that trend continues. So I would know that this would factor into x and then minus 3/2 squared, because again, this is just b/2 to get this value inside my factored form of that perfect square trinomial. Okay, b/2, -3/2, 6/2, -4/2. So that also gives me my signs there. But I should know that if it's positive with a negative, it'll be a negative in the middle. Positive with a positive, it'll be a positive in the middle. Positive negative will be a negative in the middle. We know those kind of patterns anyway, but it does help us get our signs. But when we have a fraction, it's nice to know that to get my c value, I'm doing b/2 squared, and it'll always factor into plus or minus whatever you have there, b/2. Okay, that's going to be the value, that's the second term in your factors when you're creating that perfect square trinomial. So let's look at this last one. Again, it's going to give us a fraction. So I have 5/2 squared, meaning that the c value that I would want would be 25/4. That to complete the square, I'd have x squared plus 5x plus 25/4. That's the c value that I want to add on. This creates a perfect square trinomial. And it would factor into x plus, because I have plus here, b/2, 5/2 squared. And let's just look at this. So we know that that's x plus 5/2, x plus 5/2. If I were to multiply that out, just to give you an understanding why that works, x times x, x squared, plus 5/2 x, plus 5/2 x, plus 5 times 5, 25, and 4, okay, 2 times 2. Now, when I combine the middle term here, that's going to give me 10/2 x plus 25/4, and we know that 10/2 is just 5, and it brings me back to my original trinomial. Okay, so that b/2 is always going to give me half of my b value here, half of my b value there, and then if I were to multiply it back out, it would give me my total b value back again. Okay, in terms of how we know that that works, to have that number there. So why do we care to be able to complete the square? Well, we've been graphing, and I would argue that graphing in vertex form is a lot easier than graphing in standard form. So it's nice to be able to rewrite from standard form to vertex form using completing the square. Now you'll notice here that we already have a c value. So what we're going to do, I'm going to write this on the top here, is we are going to have an x squared plus bx plus something that'll complete the square, plus the c value that was given in standard form. Now, we can't just take a function and add a number in, but if the number we add in is 0, then it doesn't change the function. So what we do is really tricky here. We add a value and we subtract the same value. And that way we're not actually changing our quadratic function at all. We're adding 0 together. If we add the same and subtract the same, but we're kind of manipulating it so that we're able to write it in vertex form. So we add whatever b/2 squared is, and then we subtract whatever b over 2 squared is. So whatever value completes the square, we also take out at the same time. Okay, and the reason we do that is because they will cancel each other out. Okay, they're going to cancel each other out and give us 0. So here, again, this already gave me a C value. I don't want to graph in standard form. I want to get it in vertex form. Well, hold on. First, let's graph it how we normally would. How about that? And then we'll look at rewriting it, okay? So if this was 2 classes ago and you had this function and we wanted to graph it, we would have to do this, right? Negative b over 2a, giving me 4 over 2, giving me an x value of my vertex of 2. And then I'd plug that in. And I'd get 4 minus 8 minus 2, or negative 6. Okay, so this is standard form. This is how we've been graphing. Negative b over 2a gives me my x value. Plug that in, get my y value. I know that this graph opens up and will follow the 1, 4, 9 pattern. So I'd go 2, negative 6, and I'd go up, over 2, up 4, over 2, up 4, and that's good. Could get a third. I could go over 3, up 9, but I think that's good. Okay, there's my graph. That's how we would have graphed before. Now we can also take this function and complete the square to rewrite it in vertex form. So to do that, I'm going to take, oops, it's minus 4x. I'm going to take a value, the value that would complete the square, and I'm going to add it in here and shift this negative 2 over. So I still have the negative 2. Here's my function. I'm going to add something in, and I'm going to subtract that same amount. Okay, I'm going to add it and subtract it, which means they're going to cancel each other out. So in order to complete the square, okay, to complete the square, we know that we take our b value, divide it in half, and square it. So my b value here is negative 4 divided in half gives me negative 2 squared gives me 4. So the value that I'm going to add in is 4, and I'll make sure to also subtract 4. So I've really added 0. The magic here comes from knowing that this beginning part that I have written here is a perfect square trinomial. So x squared minus 4x plus 4 factors into x minus 2x minus 2, or x minus 2 squared. So I'm rewriting the first 3 terms as x minus 2 squared. And then at the end of the function, I have negative 2 and negative 4, or negative 6. So I completed the square. I have these terms at the end, and that rewrote it in vertex form. Right, here's my same function in vertex form, and we can see that our vertex is 2, negative 6, and that it'll open up 1, 4, 9. It's the exact same graph. So if I were to, in my, I'm going to share my other screen. If I were to, in Desmos, enter in the original function that we had, which is x squared minus 4x minus 2, we'd have that graph, and we'd see there's our vertex at 2, negative 6. And if I were to enter it in vertex form, x minus 2 squared minus 6, you see how it just covered it up? It's the exact same quadratic. So I'll turn it off, the green one. The exact same quadratic. It's just in a different form. Okay. Let me go back to my paper. So we're going to try this a couple of times, and I'll let you try it on your own as well. So let me do, I actually want to do 2 and 3, and then I'll let you do number 1 on your own. So to rewrite this in vertex form, each time, what we're going to do is we're going to add a value right after the bx term, shove that c value out a little bit, and then we'll subtract that same value at the end. So we're going to add and then subtract, and the c value is getting kind of shoved out in the middle there. To know what value to add, I'm using b over 2 squared to complete the square, which would give me negative 6 over 2 squared, negative 3 squared, or 9. So to complete the square for just this ax plus bx pattern, okay, at the beginning here, I need to add 9. So I'll add 9, that completes the square if I ignore the tail end of that function. When I add 9, I'll also subtract 9 so that they'll cancel each other out. I've created a perfect square trinomial, which would factor into x minus 3 squared. See the negative 3 right there? Okay, comes from b over 2. And at the end, it leaves me with negative 4. So I've taken this function and I've completed the square to rewrite it in vertex form. And so now I don't have to go through all the process of graphing in standard form to find the vertex. I can now know the vertex is 3, negative 4. And it will open up following the 1, 4, 9 pattern. Okay, so I've rewritten it so that I get it in an easier form to graph. 1, 2, 3, 1, 2, 3, 4. So there's my vertex point opening up, 1, 1, and 2, 1, 2, 3, 4. That's good enough. And there's my graph by using vertex form to graph. Now, I definitely want to do 3 together because this one gets a little trickier because we're going to get a fraction when we go to complete the square. So I have ax squared plus bx plus some c value to complete the square minus 2, take away that same value. Now, when we go b over 2 squared here, we're going to have 5 over 2 squared, which gives me 25 fourths. So I know that the value to complete the square is 25 fourths. So I'll add that in and then I'll take out 25 fourths as well. And I know that my first 3 terms are where my perfect square trinomial is. And I know it's plus because positive, positive. And I know that if I'm kind of stumped here, remember that this value, this second value in my parenthesis will always just be b over 2, 5 over 2. Now at the end here, I have this kind of mess going on. So I'm going to think of negative 2 as negative 8 fourths. So then altogether, I know that I have negative 33 fourths at the end there, just combining negative 8 and negative 25 in the numerator. So here's my function now in vertex form. I would say this is still easier in my mind than doing standard form negative b over 2a, plugging it in and having to get there. Okay, my vertex is negative 5 halves and negative 33 fourths, which is negative 2.5, and negative 33 fourths is negative 8 1/4, which I think is a little bit off of my graph. Okay, so from there, I know that it will open up, and this also follows the 1, 4, 9 pattern. So I go over 1, up 1, over 2, up 4, 1, 2, 3, 4, over 2, up 4. There's my graph. Okay, so now I'd like you to try to rewrite that first function in vertex form, and then use vertex form to graph a picture of that first function up here, and then play the video and see how you go. Okay, so on our first one, and when I do b over 2 squared, I get positive 4. So to complete the square, I'm adding and taking away 4. And factoring those first 3 terms would factor into x minus 2 squared. And 3 take away 4 would give me -1 at the tail end of that function. So now I have it in vertex form, and I know that my vertex is at 2, -1, that it opens up and follows the 1, 4, 9 pattern. So I go 2, -1, 1, 1, 2, 1, 2, 3, 4, 2, 4. There's my parabola, okay?